Okay, so now what we're going to do is we're going to solve or simplify other, roots. So again, even when we had square roots, the only way you can combine these is if they all have the same root, and it all has to have it all has to be like the fourth root, right? Or the cube root. You can't mix a square root and a fourth root together. So that gives me 6. So this is going to be 2, and it's the fourth root of 3xy. Okay. And now my pages are out of order, so I got to skip all these here, and then I have to go to my second example. So now I'm going to do the fourth root of 48. So 48 divisible by 2 is 24, 2 and 12, 2 and 6, 2 and 3. So there's the fourth root. So there's 1/2 times 2, and then the fourth root of 3. And then my second one here is minus 2/3. And then I have 243 divisible by 3 is 81, divisible by 3 is 27, divisible by 3 is 9, divisible by 3 is 3. So there's 5 of them. So I can pull one of them out, and then it's the fourth root of 3. So now what I have is the fourth root of 3, because those 2's cancel out. These 3's cancel out. Minus 2 and the fourth root of 3. So this is negative fourth root of 3. Okay. And then I'm going to multiply. Again, if they have the same root, I can multiply them together. So this is 20, and then the cube root of 24. 24 is the same thing as 8 times 3. So 20 cube root of 8, cube root of 3. The cube root of 8 is 2. So this is 20 times 2, and the cube root of 3. So 40 cube root of 3. Okay, and then I can multiply again. So 6 is on the outside. I have the fourth root. I have 20 times 28 y to the 5th power. So now I have 6. I have the fourth root. I have 2 times 2 times 5 times 2 times 2 times 7. And then I have y to the 4th and y to the 1st power. So I have 4 2's now. Right, so this is 6 fourth root of 2 to the 4th. I have the fourth root of y to the 4th, and then I have left over a 5, a 7, and a y. So it's the fourth root of 35y. So now what I get is 12y and the fourth root of 35y. Okay. I'm going to multiply. So this is 5 cube root of 9 minus the cube root of 9 times 18. So 5 cube root of 9 minus the cube root of 3 times 3 times 3 times 3 times 2. Make sure I did that right. Oh my goodness. My pencil today. So that comes from the 9. That comes from 9, and then I have the 2. Okay, so now I have 5 cube root of 9 minus the cube root of 3 cubed, and then the cube root of 6. So 5 cube root of 9 minus 3 cube root of 6. And those are not the same roots, so I cannot do anything with them. Okay, so now example 6. I'm going to go ahead, and this is the cube root of x minus 2 cube root of x plus 4. So I have the cube root of x squared minus 2 cube root of x, 4 cube root of x, and a minus 8. So cube root of x squared plus 2 cube root of x minus 8. Okay, so I'm going to rewrite this as the cube root of 32x squared over 4x to the 5th power. So this would be the cube root of 8 in the top, and then I subtract my exponents, so 5 minus 2 is 3. So now I can go the cube root of 8 over the cube root of x cubed, and I'm going to get 2 over x. Okay. Again, I would rewrite this just because I have like numbers in the top and the bottom. I have variables that are the same in the top and the bottom. So I'm going to rewrite this as the cube root negative 250 n to the negative second power over 2m to the negative second power n to the fourth. Okay, so when I move my exponents around, I have a negative 250. I'm going to have an m to the first power and an m squared. And I'm going to have a 2, and I'm going to have an n to the fourth, and I'm going to move that n squared to the bottom. So negative exponents either move within the denominator to the numerator or vice versa. So now I have the cube root of 250 divided by 2 is negative 125. I'm going to have m cubed in the top, and I'm going to have n to the 6 in the bottom. So now I can separate everybody up. The cube root of negative 125, the cube root of m cubed, and then the cube root of n to the third, and the cube root of n to the third. So I have a negative 5m over n squared. Okay, now when I want to get rid of the root in the denominator, what I was doing before with square roots is that by me multiplying the top and bottom by like the square root of 6, for example, if this was a square root, is that I was creating a perfect square in the bottom. Now, if it's a cubed, I have to create a perfect cubed in the bottom. So I need not just 1 6, I need 2 of them to get me to a perfect cubed. Oops. So now this is going to be the cube root of 36, and then this is over 6, because this down here gives me the cube root of 6 cubed, and those cubed with the cube roots cancel out. Okay, so that's what we're actually going to be striving for. So now I have the cube root of 7. I'm going to split this up as over the cube root of 24. The cube root of 24 is the cube root of 8 and the cube root of 3. So this is the cube root of 7 over 2 cube root of 3. Now I have 1 3, but I need 3 of them to get rid of that root. So I need 2 more of these 3s in order to get rid of it. So that gives me the cube root of 63, because that's 9 times 7. And then I have 2 times 3 in the bottom, which is 6. So this is the cube root of 63 over 6. Because again, remember, this is going to be the cube root of 3 cubed. Okay. Now we're getting a little tricky. All right, so I'm going to rewrite this before I start multiplying stuff. So I have 3 over the cube root of 2 squared and x. So then the question is how many 2's do I need to get the 2 out, right, at the root? And then how many x's do I need to get that cube root out? So what I need is a weirdo combination of 1, 2, because that makes 3 of them, and 2 x's. So I'm going to be multiplying the top and bottom by 2x squared. So I get a 3 cube root 2x squared over, in the denominator, I get a 2 cubed and an x cubed. So I get 3 cube root of 2x squared over a 2x. Okay? And we're going to keep going. Okay, so I have the 4th root of 8. And again, what I would have done is I would have rewritten this as powers. Oops, not a cube root. Let's start over. So 2, and then I have the 4th root of 2 cubed, right? That's 8, and then an x. So I need 1 more 2 and 3 more x's. So then this is 2 4th root of 2x cubed, all divided by the 4th root of 2 to the 4th and x to the 4th. So then I have a 2 4th root 2x cubed over a 2x. Now this 2 and this 2 can reduce, so I have the 4th root of 2x cubed all divided by x. All right. Getting trickier. And then that question is question 9, so that goes to the homework assignment. So this is my last example here. So I have the cube root of 81. I have the cube root of v to the 4th. And then I have the cube root of x. Okay, so first, this is the cube root of 27 and the cube root of 3, because 3 times 27 is 81. Then I have the cube root of v cubed, and the cube root of v gives me v to the 4th. And I have all over the cube root of x. So let's simplify this. This is 3v cube root of 3v over the cube root of x. I need 2 more x's to get rid of that cube root. So I get 3v cube root of 3vx squared, all divided by x. Okay, and that is it for this lesson.